Let's unpack this. We're doing a deep dive today into a very specific, very critical piece of pro video gear.
Mm-hmm.
It's the AIDA Imaging TGEN-6P. It's a 3G SDI tri-level Genlock sync generator.
That's a mouthful.
It is. So our mission here is really to cut through all the technical jargon for you and figure out what this thing does and why it's so important in a professional setup.
Yeah, and at its core, the whole concept is Genlock. You know, if you're running multiple cameras, graphics, switchers, you need them all on the exact same page.
The same clock.
Exactly. The same clock down to the nanosecond. This device is that master clock, and it's built specifically for modern 3G and HD-SDI workflows.
Before we get into performance, we have to talk money. It's listed at $1,100.
Right.
But there's a really crucial detail in the sources. AIDA added a 15% tariff back on October 9, 2025.
Okay.
And that price, the $1,100, already includes it. So if you see it cheaper somewhere, you really need to check if that tariff has been accounted for.
That's a great point. So, okay, let's talk performance.
Yeah.
What makes this little box worth over $1,000?
Right.
Well, for one, it's truly multi-format. It supports, I think, 15 different HD tri-level sync formats. We're talking everything from 720p at 25 hertz.
All the way up to 1080p 60.
All the way up to 1080p at 60 hertz.
Yeah.
It covers the whole modern broadcast spectrum.
And it can feed a few devices, right? It's not just one output.
Yeah, that's where it earns its keep. You get up to 6 synchronized reference outputs from this one small unit.
Yeah.
That's often enough for a small control room or a field shoot.
You keep mentioning tri-level sync. For people who might be more familiar with older systems, why is that distinction so important?
Ah, that's key.
Yeah.
So tri-level is the standard for HD. It gives you precise timing information for both the horizontal and the vertical parts of the frame.
Unlike the old bi-level SD standard.
Exactly. With HD's higher resolution, that old standard just isn't accurate enough. You get jitter, you get drift. Tri-level eliminates that.
Okay, this is where it gets really interesting for me. The precision. The spec sheet says 2 parts per million accuracy.
Mm-hmm.
2 ppm.
That sounds incredibly small. What actually happens if your timing is off by more than that in the live broadcast?
Oh, it's a disaster.
Yeah.
I mean, 2 ppm is basically the line between professional and a complete headache.
So you'd see glitches?
You'd see tearing, you'd see, black frames when you try to switch sources, all sorts of nasty artifacts.
Mm-hmm.
And the way it achieves that stability is by generating both vertical and horizontal sync signals. It's governing the timing frame by frame and line by line.
It's also built to be flexible, which is critical in, say, a big venue or a stadium.
Yes. So it can be the master clock, but it also has a really robust slave mode.
And that's for scaling up, right?
Exactly.
Yeah.
In slave mode, it can take an external reference signal and then just distribute clean, reclocked copies of it down the chain. So you can cascade these things across a massive facility, all locked to one single master source. And physically, it's tiny. The sources say it's just over half a pound. Controls are pretty straightforward. 2 DIP switches and a little LCD screen.
Right. It's meant to be tucked away. And for inputs, while the output is tri-level HD, it can actually take in either tri-level HD or the older bi-level SD as a reference. So you get some backwards compatibility there.
Good to know.
And one last thing, the vendor support your sources mentioned is pretty solid. Free shipping in the US, a 2-year warranty, and lifetime tech support. It's a good safety net for a mission-critical device.
So to bring this all home for you, we've talked about its 2 ppm precision, its 6 outputs. But this makes me wonder, especially with that slave mode.
Mm-hmm.
Here's a thought to mull over. When you are cascading multiple units, distributing that sync reference over, say, thousands of feet of cable in a stadium, what do you think is the one physical or electrical factor that could start to threaten that critical 2 ppm stability at the very end of that long chain? Something to think about when you're designing your next big system.